Okay, this video goes with the mathematical literacy part of the 6.2 notes packet. So a kite is defined as a quadrilateral with two pairs of consecutive congruent sides. In a kite, no opposite sides are congruent. They're consecutive pairs of sides that are congruent. In a kite, segments that connect two non-consecutive vertices are perpendicular to each other, and we call those the diagonals of a kite. Also, let me sketch one in here. So if I sketch this kite in here, this major diagonal is the perpendicular bisector of the minor diagonal. So we call these diagonals. This one's major because it's the long one. This one's minor. And they are perpendicular, and the major bisects the minor. So the matching congruent marks, and you got a right angle mark there and a right angle mark there. Okay, let's see what else we got. A trapezoid has exactly one pair of parallel sides. It's a quadrilateral. With exactly one pair of parallel sides. And we call the non-parallel sides legs, and we call the parallel sides bases. So the legs of a trapezoid are the non-parallel sides. So in this diagram, AD would be a leg, and BC would be a leg. So those would be the legs in that trapezoid. Now let's look at the next one. The parallel sides are the bases of a trapezoid. So again, if we draw trapezoid, so we have this one. These are the parallel sides. Those are the bases. So we call this base 1, we call this base 2, or vice versa. And at some point, see that the length of this mid-segment, which is the middle point of the two legs connected together, is actually base 1 plus base 2 divided by 2. It's actually the average of the two bases. Let's see. The base angles of a trapezoid aren't necessarily congruent, but if you have an isosceles trapezoid, the base angles are congruent. So an isosceles trapezoid has these legs as being congruent to each other. So let me mark those as, so here we have the bases, the parallel sides, and let's mark EH congruent to FG. Now this sets up what we call an isosceles trapezoid. Which has special properties that a regular trapezoid doesn't. In an isosceles trapezoid, the diagonals are congruent, so we would have EG equal to HF. Diagonals are congruent, and also the base angles are congruent. Angle E is congruent to angle F, and angle H is congruent to angle G. Now that only works in an isosceles trapezoid, which has the two congruent sides. And then the base angles are congruent. So base angles of an isosceles trapezoid ZOID are congruent. The mid-segment of a trapezoid is the segment that joins the mid-segments. So if I draw a trapezoid, So here we have a trapezoid. Here's the parallel sides. Here's the midpoint of one leg, midpoint of the other leg. It's halfway between the bases. If this was 15 and this was 30, the length of the mid-segment would be the average of 15 plus 30, and you would divide by 2. So 45 over 2 would be 22 and a half. So this length would be 22 and a half. If you knew what the base was, let's do another one. Let's say you knew that, let's say you knew this mid-segment length was 18, and you knew that one of the bases was 10, and you needed to find out what the other base was. Then basically, if you double the 18, you get 36. So 10 plus x must equal 36. X must be 26. So if you take 26 and 10, you get 36 divided by 2, you get 18. So again, the average of the bases is the mid-segment. Double the mid-segment is the sum of the bases.